We want to go ahead and estimate the slope of our tangent line. Whenever you're trying to find the slope of the tangent line, it's your AROC formula with the limit in front. That's your instantaneous rate of change. Instantaneous rate of change always tells you the slope of the tangent line. So we're going to go ahead and take our x plus h, plug it in here for x, minus our original function, all over h. So then you're going to FOIL out the top here. There's supposed to be a 2 here in front of this h squared. So we have that fixed. So now we're going to collect our like terms. We have a 2x squared, a negative 2x squared. They're going to drop, so we're just left with this here. Then you'll notice everything has an h. So let's take an h out of the top and the bottom, and we end up with this. Now that we no longer have that h in the bottom, we can actually plug in 0 for our h, and we get 4x. 4x is our slope predictor function for this original problem, which would allow us to be able to find the slope anywhere along our function, as long as we know what x is. So in other words, our slope predictor function is 4x, but we know x is 2 according to our problem. So we got to plug 2 in for our x, and we get our slope of 8. So now you'll eventually have to go ahead and find the equation of your tangent line. You just figured out the slope, which is 8. But to figure out the equation of your tangent line, you also need to know a point. Well, we knew that x was 2. We take 2 and plug it into your function. 2 squared times 2 gives us 8. So we have our point of 2, 8. Then you should be able to go ahead and use your point slope formula to be able to find the equation of your tangent line. We're doing pretty much that same process for all these. So we got to do our instantaneous rate of change on this one here. And we get this here. But at this point, you have no way of being able to get the h out of here so that you can plug in 0. In situations like this, you want to use your calculator. So go ahead to your calculator, put it into your y equals, and then you want to make sure that you're using your table. If needed, change your table to ask, and then you can go ahead and type in numbers close to 0. If we look at our table for this, we would get this right here. Notice when we plug in 0, it says we get an error because you get 0 over 0, and 0 over 0 is indeterminate. But down here we're plugging in numbers close to 0, and you'll notice we get an answer for our slope. So our slope is estimated to be this, and we have our point in this case of 2, 9. How do we get the 2, 9? Well, our x is 2, and we plug 2 into our function, and we get 3 squared, which is our 9. Then we have our log in our trig function down here. We want to do pretty much the same thing. Set up our IROC formula. Now, we can only put this into our calculator because there's no way for us to algebraically solve it. Then you want to go second table and look at your table. And what we have right down here is our estimate of our slope. So we have an estimate of our slope. We have our point, 2, what we get when we plug 2 into our function. And then you should be able to find the equation of your tangent line from there. Similarly over here, we're going to go and do our IROC formula for the slope of our tangent line. Plug in 2 plus h minus what we get when we plug in 2. Once again, we cannot algebraically work that out yet. So we go ahead and use our calculator, putting it in our y equals, setting up your table, making sure your calculator is in the radian mode. Then we have our slope, and you have your point, so you could find the equation of your tangent line.